Let's look at example 3. Example 3 is looking at maximum power transmission condition. So before we solve example 3, let's look at maximum power transmission condition once more. So what happens is, when the question specifies that we're looking at maximum power transmission condition, so the first thing that you need to understand is that your centrifugal tension is given by expression 15, which is stating that your centrifugal tension is simply 1/3 your maximum tension. So capital T over 3, and then you will calculate your velocity for maximum power transmission using equation 16. You won't use V is equals to pi dn upon 60, but you will use this relation, which states that your velocity is square root of T over 3m. M is the mass of the belt per unit length. So now let's look at example 3. So in example 3, a flat belt is given, which is 200 mm wide and 15 mm thick, and it runs between two pulleys. The allowable strength of the belt material is 3 megapascal. You have to determine the maximum power that can be transmitted. The tension ratio is given as 4, and the density of the belt is given as 1000 kg per meter cubed. And the question clearly states that it's a maximum power transmission condition. So let's look at the main tension ratio. Tension ratio is simply T1 over T2. So T1 over T2 is given as 4. The density of the belt material is given, and then we know that we're looking at a maximum power transmission condition. So with these things, what we can do is, we know that your maximum tension, which is nothing but the total tension on the slack side, which is TT1, is simply equal to your sigma times the cross-sectional area. Sigma, the allowable stress, was given as 3 megapascal. The cross section of the belt, it's a flat belt, so the width and the thickness was given to you. So width was 200 mm, thickness was 15 mm. So once you find the value, you end up with the value of 9000 newtons. So your maximum tension, which is simply equal to the total tension on the tight side, is equals to 9000 newtons. Now, since we're looking at maximum power transmission condition, so naturally your centrifugal tension is going to be maximum tension divided by 3. So your maximum tension, which was simply a total tension on the tight side, which was 9000, divided by 3 is 3000. And this is the relation that we used a little bit earlier. So your total tension on your tight side, which is TT1, is simply equals to T1 plus TC. So we can make T1 the subject of the formula. So T1 is nothing but TT1 minus TC. So TT1, as found earlier, was 9000 minus 3000, which is 6000 newtons. So T1 is 6000 newtons. The tension ratio was given as 4. So your tension ratio simply is T1 over T2. This time around, you don't have to do exponential mu theta, because you are given your tension ratio, which is T1 over T2, which was equals to 4. So solving for T2, you get your T2 to be 1500 newtons. So you've got your T1 and T2. The next step is to find the velocity for maximum power transmission. So we know that your velocity for maximum power transmission is given by square root of capital T, which is your maximum tension, divided by 3m. M is the mass of the belt per unit length. So then mass is density times volume, and volume is nothing but cross-sectional area times the length of the belt. As mentioned earlier, we take the length of the belt to be just 1 meter. So density was 1000. The dimensions of the belt, the width was given as 200 mm, converting it to meters, 15 mm, convert that to meters, and then the length per length of the belt, we take that as 1. So what do we get is, we get the mass of the belt to be 3 kg. So now we can substitute m into this formula. So your velocity is simply 9000 divided by 3 into 3, and we get our maximum velocity for maximum power transmission condition to be 31.62 meter per second. So now let's substitute everything that we got. So T1 was 6000, T2 was 1500, velocity 31.62. So we get our power, and this is the maximum power that can be transmitted by this belt drive system, to be 142.3 kilowatt. So once more, this question clearly states that we're looking at maximum power transmission condition. So please be reminded that you don't use TC is equals to mv squared to find your centrifugal tension for maximum power. Centrifugal tension is 1/3 the maximum tension, so 3000 and we know that your maximum tension is nothing but TT1, which can be also given as stress times the cross-section area, which was 9,000. Now what we do is we can find T1 using this relation. So we get 6,000. Using the tension ratio, we get T2 to be 1,500. Finding the velocity, you need to find the mass. So mass was 3 kg of the belt. Substituting everything, we get our velocity, and finally we get the maximum power to be 142.3 kilowatt. The next thing that we're going to look at is the initial tension in the belt. So when a belt is wound around the two pulleys, its two ends are joined together so that the belt may continuously move over the pulley. And then what happens is the motion of this belt is governed by the frame grip due to friction between the belt and the pulley. In order to increase this grip, the belt is tightened up. At this stage, even when the pulleys are not rotating, when they are stationary, the belt is still subjected to tension, is called your initial tension. You can find the initial tension using equation 17. So initial tension T0 is simply equals to T1 plus T2 plus 2 TC divided by T is the tension in the tight side, T2 is the tension in the slack side, TC is again your centrifugal tension, and T0 is the initial tension. So what we'll do now is we'll look at an example which deals with initial tension. So example 4 states that in a flat belt drive system, the initial tension for a flat belt drive system, the initial tension in the belt is given as 2000 Newton. The coefficient friction between the belt and the pulley is given as 0.3. The lap angle or the wrap angle is given as 150 degrees. The smaller pulley has a radius of 200 mm and it rotates at the speed of 500 revolutions per minute. What it says is you have to find the power transmitted by this belt. So again, what happens is in this type problem, initial tension is given. It does not mention that it's looking at maximum power transmission condition. So this is similar to examples 1 and 2 that we solved in the previous videos. So again, the main things that you need to understand is the initial tension is 2000. A coefficient of friction is given as 0.3. The wrap angle or the angle is 150 degrees. Speed at which the pulley is rotating is 500 revolutions per minute, and the radius of the pulley is given as 200 mm. So list the variables that you know. So T0 2000 Newton, the wrap angle was given as 150 degrees, the radius of the pulley was 200 mm, the speed at which the pulley is rotating was given as 500 revolutions per minute, and the coefficient of friction was given as 0.3. So the first thing is you need to convert the wrap angle that is given is degrees into radians. So theta is simply 150 over 180 times pi. So you get your wrap angle as 2.62 radians. Your velocity, you can calculate your linear velocity. So it's simply given as pi dn upon 60. So what happens is the radius was given as 200. So diameter is 400 mm. So converting that to meters, speed was given as 500. So the velocity equates to 10.47 meter per second. Now what happens is we can calculate our tension ratio. Tension ratio is again T1 over T2 is equals to exponential mu theta. So coefficient friction was given as 0.3. Your lap angle was given as 2.62 rads. So evaluating, we find our T1 over T2 as 2.19. So your tension ratio is 2.19. So therefore T1 is 2.19 T2. So again what I did over here is T1 over T2 is equals to 2.19. So I made T1 the subject of the formula. So I get T1 is equals to 2.19 T2. Now what happens is this expression we already know. Your T0 is equals to T1 plus T2 plus 2 TC divided by 2. One of the things that you need to understand is that in this problem, it does not mention, it does not give us information regarding our centrifugal tension. So what we can do is we can simply say that our centrifugal tension is simply equals to 0. However, in some problems, it would mention that centrifugal tension needs to be accounted for. So density of the belt would be given for you to calculate the mass, and then based on the velocity you can calculate your centrifugal tension. But in this case what we see is that it does not mention anything about your centrifugal tension. So simply what we can do is we can say that Tc is equals to 0. So what we can do is Tc simply equals to 0, so that T naught is equals to T1 plus T2 over 2. So from the previous step we knew that T1 was 2.19 T2, so in place of T1 substitute 2.19 T2 plus T2 over 2. So what we get is T naught, initial tension was given as 2000, so 2000 is equals to 3.19 T2 over 2. So therefore we can solve for T2. There's only one unknown over here, so T2 is equals to 1.25 kilonewton, and T1 is simply obtained using this relation. T1 over T2 is equals to 2.19, so it is equals to T1 over T2 is equals to 2.19, so therefore T1 is 2.75 kilonewton. Now what we do is we know T1, T2. So we know that the power is simply given by T1 minus T2 times your linear velocity. So T1 was 2.75 kilonewton. T2 was T1 was 2.75 kilonewton and T2 was 1.25 kilonewton. So multiplied by the linear velocity, we get our power that can be transmitted by this belt to be equal to 15.71 kilowatt.